Guten Tag, Stephanie.
Guten Tag, Michael.
Last time we downloaded Python and several packages, and today we'll download CWatM, the community water model, as well as input data to run the model.
At last, now to the model.
Yes, a class to the model. Could we go to a browser and search for CWatM?
So I'm using Google Chrome.
CWatM. And then GitHub, space GitHub. So we hold the model on GitHub. GitHub holds different repositories. Let's choose this first link, github.com/IIASA/CWatM.
Okay. Question, because you told me to go to a browser. Is there a browser? Is there any that does not work well with this?
For downloading CWatM, all the browsers should be fine. Later on, when we start using something called Jupyter Notebook, I've noticed that Safari on Mac doesn't work as we expect it to, but testing it with Chrome and Firefox, they work properly.
Okay.
Okay, here is the link to the model, but before we download the model, I want to download the climate data, which is going to take some time. So if we start off by downloading the climate data, by the time we're finished downloading the model and maps, perhaps this climate data will be finished downloading. So if we scroll down on this page.
Question, Mikhail. When you say climate data, where is this data from?
Yeah, this data is from the EasyMIP consortium. EasyMIP stands for an intermodal comparison project that is with the objective to harmonize how modeling can be done and tested against each other. So EasyMIP has provided this climate data for historical period as a hybrid of things that are coming from remote sensing as well as ground truth tested data. But so a mixture of observations from remote sensing satellite products and then ground truthed or ground observations like rain gauge stations.
Okay, got it.
Let's scroll to the bottom of this page, and we're looking for a link.
A link.
So right here, I scroll up just slightly again, just towards the beginning of this description, right? Can you right-click and open in a new tab this CWatM-Earth-30 minute?
So this user manual and model documentation?
Just two sections down, where it says our repository CWatM-Earth-30 minute.
Okay, the CWatM, okay.
Yeah.
In a new tab.
In a new tab, yeah. And then let's go into the second tab. So this tab holds input data to run the model, like the lakes and reservoirs, the way that water moves along rivers, the soil, the amount of water that plants and crops use, the land cover fraction. We'll also come back to this, but if we scroll to the bottom of this, we'll get the link to the climate data. So we're opening everything and then we'll return to everything step by step.
Okay, so it's just letting everything that we're supposed to download go simultaneously.
Yes. So okay, just near here, a little bit lower. Yeah, you see this link in the second bullet point. At the end, it says downloaded from Google Drive.
Just sorry.
Alternatively, this
so
can be downloaded.
Climate. Okay.
Yeah, let's open this in a new tab. This is going to be climate data. That includes minimum, maximum, and average temperature, pressure, precipitation, radiation, short and long wave, relative humidity, wind, and I think I said pressure. Let's download this.
Any viruses?
I hope not. Shouldn't be. And this is daily.
So this is the Earth data that we are now downloading.
This is just the climate data. So this is climate data for the whole globe at 50 kilometer by 50 kilometer resolution daily from 2011 to 2019. It's 20 gigabytes It's quite large, so it may take about a half an hour to download, I guess, on this computer with this connection. We'll see. But now let's busy ourselves with the computer, or sorry, with the model and other input data. So let's go to that first tab we opened. Yeah, the first tab, we can click it.
I lost you a little bit, but I hope you can hear me.
Okay, I think we're back. Okay, so this is the community water model. The model is held on GitHub.
Can you hear me?
I can hear you. Can you hear me? I think we have the connection back.
Yes, I can hear you.
Okay, maybe there's a bit of a lag.
Technology for us. Yes.
So the model is held on GitHub. GitHub allows us to update the model and share these updates with users relatively easily, or at least with the click of a button. Before we can download something from GitHub, we're going to have to download something called GitHub Desktop. That will allow us to interact with different repositories on GitHub. We see that this is a repository, and the second tab is also another repository. Repositories are like folders holding either data or different programs. So let's open up a final tab and search for...
So we are opening another tab.
Opening another tab, and we will search for something called GitHub Desktop.
Okay, GitHub.
So GitHub Desktop, yeah, DESKTOP.
So with the GitHub Desktop, we don't look for it within the GitHub tab that we looked, but it's a new browsing material in itself.
It's a program that we'll download, and then we'll go to these tabs and say to find the location of these repositories. So GitHub Desktop is a program that allows us to interact with GitHub to update or to download some of these repositories. The first step is just to download GitHub Desktop.
Okay.
There are other ways of interacting with GitHub, but GitHub Desktop seems to be one of the more friendly versions. And also my preference.
Is it this first one?
This first one. And we can go right away and click download for Windows 64-bit.
So with this second step, someone has to have at least good internet.
Yeah, to download the climate data, one will need to have a stable and good internet connection. We are working on a smaller climate data set just of 1 year so that it's easier to download. But if one has access to a good enough connection to download 10 years of data, it offers a little bit more flexibility to play with the model. But in any case, we'll put a 1 year data set on there soon enough to facilitate other connections. Can we click on that down arrow towards the top of the browser, the top right of the browser? See if it's downloading GitHub Desktop.
Okay.
Yeah, okay, this is almost finished. And the other one will be 2 hours. So we'll come back to it at the next video.
Okay.
As we can see, even our connection is a bit laggy. So someone is using the internet connection at IIASA.
Yeah, it's like a cook show where we say, "Oh, this are the ingredients," and then later on the.
Yes. Maybe could you go try that again? Go to that down arrow and then click the GitHub Desktop exe.
I did click it.
Yeah, that's clear.
I think nothing else happened. Let me just try.
Could you open the folder with GitHub Desktop in it? Ah, there it's something's happening. I wonder
Yeah.
if the data download is just slowing down the computer. Perhaps we pause the climate data download and we come back to it at the end of this video.
Okay. So I will just pause it. I could click the hub again.
Friday afternoon, even the computers are tired.
Yeah, they're on a break. They're like, the weekend has started. So with this, I'm discovering it's like locating things, installing spaces for it to work with this whole process compared even with the first. It's like such a game.
It's a game. It's finding things in certain places, but step by step. Okay, so this thing, it says sign into GitHub, but this is not necessary. It's a little bit written strangely, but you'll see. Oh, if we go back to that screen, if that's possible. Okay. So where it says new to GitHub towards the left, and just below it says skip this step. It's just awkward because our font size is so large.
Okay, so I could just maximize this.
I think it'll stay the same. But if you go to the left and just try to click skip this step. Yeah. It's awkward because the text size we've created is so big. You've almost got it. I can see it appearing sometimes.
Okay, we are playing another game here. Okay, we could do this for now.
Perfect. Okay.
And then
put our name in here. Perfect solution.
do I need now to...
You don't have to put your real name, but you could put your real name. This is just to sign things if you change anything. We're not registering for an account here. Yeah, put Steph, and then you can put your... Maybe put your real email here just in case it does connect us if we do want to register for you an account at a later point.
Okay. Will I be expecting new emails from our viewers?
Yeah, sure. No, we see. Okay, perfect. So let's click this clone a repository from the internet. What we're going to do is clone CWatM from the internet. So we can click this button, go to the URL, and now let's go to that first tab we opened.
The first tab we opened on GitHub.
Yeah, exactly. Perfect. Now we have to find this, if we go to this code button, there's this big green button that says code. Yeah. And then copy this to clipboard. Exactly. So this is going to tell GitHub Desktop that we want it to download this repository, basically the CWatM model.
Okay.
Now let's go to the GitHub program. Perfect. Paste that in here. Perfect.
Question, when it says local path, what does that mean?
That's where it's going to put it on your own computer.
Okay.
You can change this as it's appropriate. It'll put it in a folder called GitHub, which is good, but other than that, you can put it anywhere you want.
Could I choose it to be maybe in the downloads or something?
Yes.
On the desktop, just let's see if we...
Somewhere maybe that you're familiar with, yeah.
Okay, I'll just leave it downloads. Okay, let me just let it be because I think... Okay. Documents.
Okay, and one thing I just want to change, so it's documents, which as long as fine, it's just as long as we know where it is. But I want to put it in a GitHub folder. So before CWatM, could you write in capital G, just in the local path? I want to put CWatM in a folder called GitHub.
So I removed this CWatM.
Keep CWatM. Just before CWatM, let's include the word GitHub. So like a backslash, and then capital G, IT, capital HUB, and then backslash,
Okay, this is when you know you don't know your keyboard.
Yeah, my keyboard is also different time to time.
Um,
You can also copy. Yeah, great. That's what
yeah.
Sylvia also does.
Um, yeah.
Okay, so now we're just going to put it within a GitHub folder. I think that's nice. Just so everything we take from GitHub, we keep in the same space.
So in my case, because I've saved it in my documents, the folder will be GitHub. Or-
There will be a folder called GitHub inside your documents folder.
Okay, got it.
Yeah, and then we can go ahead and click clone. So cloning is like downloading CWatM on your computer. But if I ever create, or anyone from the development team, or even you eventually create changes to CWatM, then people can pull these changes on their cloned CWatM. So it's like a download that
Okay.
always stays connected.
Mm-hmm. So it takes a collection of different work within the. Will I be right if I say repository within this CWat model?
It's taking the whole repository that contains CWatM, or the CWatM repository. Or like we can think of the word repository really as folder that has like changes a long time held within its history. So we can tell when things have been updated, and we can stay updated when new changes come into it.
It's like a live library when you add books.
Like a live library. Yes.
That's the first thing that came to my mind.
Yeah, we could call it a CWatM library, with each folder being a different book collection. Okay, that worked. You have CWatM on your computer. Just because we're going to be dealing with a version of the model that plays with some more updates, it says this current branch right here towards the top.
Yeah.
Yeah, can you change it to beta? So there's different branches. There's the development branch that we're playing with, and there's many regular updates. Can you change it to the beta branch? Beta branch gets updates perhaps every month, and the main branch is just when we release a new version. But since we'll be playing with relatively new updates, we'll play with this beta version. But we won't have to change this again.
Michaela, just a question.
Please.
So there is the develop other branches. So we have the main develop pages. Could you just go back and explain what each? You said one does monthly, another one on the spot.
They all hold different versions of the code, or the develop branch, when I make a change, I'll immediately push it to the develop branch. So develop is the most up-to-date, but it's possible that there might be something on there that we want to remove again. So it sees the most amount of movement. But when we want to share a version of the code with users, or particularly users that are using new developments of the model, like if we're playing with something and we decide to update something as a result of our conversation, I'll put it in the develop branch. But then since you want to use it, I'll push it right away to the beta branch. So the beta is sort of like where the beta users, or the more recent users, can play with the model. Main branch is after we've had 6 months of playing with different developments on the develop branch or the beta branch, or when we release an official new version, we put it in the main branch.
Okay. There is a hierarchical
Yes.
aspect to this. Okay.
Yes. But beta branch, we can keep it there for us, and we won't have to change that again.
Okay. Got it.
Okay. One last thing we'll do together is to download the input data for CWatM. So this is the model. Then we are downloading, or we will download at the end of this video, we'll push play again on the climate data. But what we want to now download is the other input data. This is stuff like the rivers, the lakes, or maybe not the rivers, but the way that water flows along land, where the lakes and reservoirs are, and certain information about them, certain soil characteristics, groundwater characteristics, land cover characteristics. So basically what allows us to build the virtual world that we will then put the climate on top of.
Question. When we talked of the climate data, you talked about pressure, precipitation, long wavelength, short, or radiation. So what's the difference of that with this? Because with this, I hear also more geological or geographical features.
So one is so we have the climate. The climate will force or expose our virtual Earth, our virtual world, to different temperatures, pressures, and rainfall. But when that rainfall falls, we want to know what it falls upon. What kind of vegetation or land does it fall upon? How does the water move along the Earth to form rivers? When does it get stuck in lakes, or when does it come into lakes and reservoirs? What kind of soil does it seep into? What is the relationship between surface water and groundwater? So this next input data set we'll download builds maps of this virtual world, while the other one was just the climate. So sort of the atmosphere that affects the Earth, and now this virtual Earth.
So climate is almost like a remote where you're inputting all these factors.
Sure.
Yeah, okay, got it.
Okay.
And then the input is now what the other thing that is interacting with all this climate data.
Exactly. Like the stage with which the climate data plays upon.
Okay, got you.
Okay, let's go to that browser again and open up a tab. Or sorry, go to the second tab. We just want to find the link of that input data. So yeah, here, and scroll to the top of this.
So the second tab was
this one, yeah, the CWatM Earth 30 minute. And let's click that green button again. Code. And type copy to clipboard. Or sorry, click copy to clipboard. Perfect. Let's go back to GitHub.
Desktop or?
GitHub Desktop, you're a step ahead of me. At the top left menu, can you click on File?
File.
And then Clone Repository. Perfect, type it into here. We see it remembers where you put the GitHub folder last time. So now it's going to put this within the GitHub folder within your documents, users, user. And now we push clone. So this is
the inputs.
These are the inputs for the whole globe at a certain resolution, 50 kilometer by 50 kilometer resolution.
And question, so with like you're saying inputs from the globe, where do all this data, for example, come in with this, for example, the one in the inputs?
Yeah, it's a collection of many different sources. We can say the soil data, for example, comes from a data set called the Harmonized World Soil Database that actually collects soil classification and textures at a 1 kilometer resolution. We translate this into soil water parameters like how much water, called residual soil water content or saturated soil water content. So the soil comes from the specific database called the Harmonized World Soil Database. The lakes and the reservoirs, they come from something called hydrosheds or hydrolakes. That uses a mixture of remote sensing and ground truth observations and studies to show the shapes of lakes and reservoirs, as well as the year of construction, the area, the volume. Then we have something called the river network, or if water falls in a certain cell, how do we know which cell or where it's going to flow to? We build these maps from elevation maps. From these, we can derive maps of channel width, channel depth, channel roughness, channel slope. If data on these parameters don't exist, we can derive them with certain empirical formulas. Then we have land cover. For each cell, how much of the land is covered in grassland, forest, irrigated agriculture, regular agriculture, or not regular, but non-irrigated agriculture, water, or urban environment. And there are many different data sets that show land use classifications. So CWatM is sort of collecting a lot of disparate input data sets to build this virtual world. In fact, while this is downloading, let's go look at the CWatM manual that describes all of this input data in detail.
Okay. So I go to another tab.
Yeah, go to a browser again. And let's type in CWatM. And let's just search CWatM and then CWatM space IIASA. And let's see what comes up.
You could just maybe tell people what IIASA stands.
IIASA stands for, the International Institute for Applied Systems Analysis. That's where both of us are right now.
Yeah, it's usually unique. The pronunciation is usually different with what one reads.
Sure.
Yeah.
In fact, let's not go to this link, but let's go back a page.
Okay, back.
We're looking for this second link, the CWatM.IIASA.ac.at.
So the one that starts with CWat.
Yes. Okay, so here's generally the manual of CWatM, but we're going to go specifically to scroll down slightly so I can see something lower on the menu. Yeah, let's go to number 10, data on the left.
Okay.
And let's scroll down here. So if anyone is interested at least in this 30 arc minute data set that we're using now, it is all referenced and talked into some level of detail here. Let's scroll down until we find something about the soil, for example.
Okay,
so here's the land surface, talking about the elevation that lets us build the river drainage map. These are the different channel depth, channel length, gradient properties.
I'm just so curious, how many years of data is this?
Well, most of these maps just represent like the channel maps or the river maps represent just they don't represent a single year. We have one map to represent some maps move through time, like land cover. Land cover, the distribution of forests and grasslands or irrigated agriculture or urban environments. This obviously changed from like 1900 to the present. Urban environments keep growing, agriculture grows, forests decrease, or in some places forests increase. But the river map, or this lakes and reservoir map, or more particularly the river map, is a static map, so it doesn't change through time. I mean, ideally, actually, if we're going even earlier times, we can have the morphology of the river moving through time, the path of the river moving. But in this example, we have a static map for the river. Lakes and reservoirs are a little bit different because reservoirs do come with a construction year. So before the year of construction, the model has it either as a lake or just as a part of a river. So some of the maps have a time dimension, and some of the maps are just static. Okay, let's go back to GitHub.
And question, just because we're on the topic of maps, what happens, for example, like what we say, like Lake Chad decreasing in size? What is that category? It's not still not a static map. So in such cases, with features changing,
Sure.
years, how is that?
So something like the storage within a lake or the volume within a lake is something that's modeled within the community water model. So in an environment that's abstracting more and more water from a lake through many years, or the precipitation is reducing over many years, then the volume or the storage of that lake will decrease through time. So these like lake and reservoir parameters are sort of just the boundaries that we simulate within, and that affect evaporation. And affects the maximum volume of the lake, for example. But if the lake meets that maximum storage volume or decreases through time, that's something that we would simulate with the model. Okay. So exactly something like Lake Chad reducing in size or the storage of Lake Chad reducing through time would be something we would want to simulate with the model.
Okay, got you.
Let's just go back to the GitHub Desktop.
Okay, the GitHub Desktop. Today's a lot of downloadings.
Today's a lot of downloading. The next time's going to be finally a little bit more playing.
Yeah, we got to set the playground before playing.
Yeah, we have to make the playground before playing.
But so for someone what would be your advice for someone who wants to start this in terms of either a student or how relevant do you think it will be, especially for people who still don't or early careers or even students within their bachelor's or master's? How do you think it will be relevant in terms of them trying to understand their field, especially within hydrological sciences?
Totally. I mean, if one is interested in looking at the environment or the relationship that humans have influencing the water cycle, the influence that the water cycle has on us. I think, following these videos and going through step by step, we can begin within a couple hours already experimenting and learning about the water cycle for different regions around the world. So if one is interested in learning a little bit about the water cycle in their region or in another region, the inflows, outflows, how it changes through time, how it's different in wet years and dry years, how the seasonality of an area, when is the wet season, when is the dry season. Many of these things might be obvious for someone in a region or interested in another region, but sometimes the results of the model can be really surprising. To go through and see where they're, right now I have the opportunity to study the Danube Basin, where we're currently living in. And as you'll see as we go through these videos together, we compare the model to satellite imagery, and using this to develop some confidence in the model, we can explore what the Danube Basin has been like for the past century. And we notice patterns that somehow we didn't expect. This decadal seasonality, years of flood and then years of drought. So using this, I was able to ask questions. What would we do if we knew we were in 10 years of drought? What would we do if we knew we were in 10 years of flood? I guess what you can do with the information from learning about the water cycle in your region or region of interest, we will see once you have that information. And I find it fun and playful, and you'll see the next time the maps and figures we create are interesting. And the worst thing they can do is encourage a conversation about the water cycle.
Yeah, no, and I also find it interesting as someone who's this not an area of expertise, that it's open access, first of all, and like the way right now I'm learning. And number two, making sense practical.
Sure.
Anyone, because if you did all this or trying to understand the way you're saying the Danube right now in writing will be a little bit difficult, but seeing and experimenting just within your own space or by yourself gives you a different perspective and also makes learning interesting, so and interactive.
Agree completely.
Yeah. And I think it also allows us to make our own conclusion.
That's exactly what I love about this. Let's not convince each other of things that we have found, but let's play with it ourselves and see what we learn from the experience.
Yeah. We are almost there. So within this, in terms of so far, what you've downloaded is the climate data, which will continue downloading later to be continued.
To be
And then now
continued.
the GitHub Desktop that allows us to play with all these repositories, and now the inputs.
And now
Rather,
the
that
inputs.
way. Okay.
All the inputs other than the climate. So yeah, three things: the model, the climate inputs, and then all the other inputs that build this virtual Earth.
Okay. There's that. I think with this stage is a game of patience.
I can always benefit from practicing patience. What basin do you want to explore together?
Definitely where I'm from. So I'm Kenyan. I'm from the Western region. Definitely Lake Victoria. Sorry, guys, I'm going to be biased.
I look forward to it. Let's learn about Lake Victoria Basin together.
Yeah. So just that background maybe of Lake Victoria, it's in East Africa, shared by, you can correct me if I'm wrong, if my geography is wrong here, mainly three countries. Then the Lake Kenya, Uganda, Tanzania. Have I left out a country?
And maybe Burundi and Rwanda are also
Yeah.
within the Lake Victoria Basin.
Yeah. So I will be interested to see how that, what hydrological cycle there is affected by different factors.
Yep. And the Victoria Basin is the upstream part of the Nile Basin.
And for you, with this particular model, have you worked or has the research group worked within the Lake Victoria region?
Yeah, in fact, actually, yes. There's been a program through the Austrian Research Development Agency, or the Austrian Development Agency, to work particularly close with Uganda, but the whole Lake Victoria region. In fact, the Lake Victoria Basin Commission was a partner on our recent project called Scaleways. But even before Scaleways, there was a follow-up project leading into this. It is a wildly interesting area to study, growing significantly, an enormous amount of water, in fact, but interests to grow. Well, I guess it all depends where you are. I mean, you're familiar with this as well, but there are some very dry parts of the Lake Victoria Basin and then some very wet parts of the Lake Victoria Basin.
And with this, in terms of understanding using the model to understand the region, does it later on go back into something solid or influencing policy or anything of the sort of guiding? At the end of the day, with all this exercise and research, where does it go?
Well, this recent project, Scaleways, through stakeholder engagement, two questions that were of interest to the region were, is it possible to grow rice in the region sustainably? Rice is also known as a water-intensive crop, but when water is available, is it possible to grow rice sustainably? Also, as the region is experiencing increasing demand for rice, particularly local varieties of rice of certain aromas. So it's a food security question, it's a water question. And at the same time, another question that came up from the project was, what is the future? How can we support livestock? Using the hydrological model, as well as another model that simulates crop potential, the idea on where rice could be grown sustainably, where rice is available, and not just generally, but in wet years and dry years, and where could rice be most productive. Overlapping these two gives us an idea of perhaps hotspots that we can focus on for rice production. This is somehow just the biophysical version of the question and that part of the project, but it goes further into discussing how can certain community practices or sustainable practices also support higher yields, or the transition of technologies in the form of practices and water-saving technologies to support rice development in the region. So Scaleways has just come to a close, but the River Basin, or the Lake Victoria Basin Commission, was a partner in the project. There were several workshops with experts about rice and livestock that attended, gave their strengths and weaknesses and opportunities and challenges for these questions as a part of the project. So well-guided, biophysically related, and then significant interviews to decide how can community practices support such an initiative. Actually, this is downloading. It's a great opportunity for us to discuss. Can we open up another tab? And
Yes.
let's actually, Scaleways has a web page.
Okay, so scale. Question, you said pages. When we opened the GitHub, there was also the better made pages. By any chance, does it go there?
Pages relates to the website that we had downloaded that had the user manual.
Okay.
Yeah, so that we don't touch, but that's just a way of connecting the web page or the user manual to the GitHub. Yeah, Scaleways, you typed it perfectly. SCALEWAYS. Space, let's type in IIASA and see if the website comes up. Or with us, yeah. Perfect. Scaleways-eastafrica.com.
Okay.
Let's click this. So we can find more information about the project here. Publications, this community of practice. But all to say, in fact, I can always benefit from learning more about the Lake Victoria Basin and see what questions. Together we'll look at also satellite imagery from Lake Victoria Basin, which I haven't yet done as a part of this project.
So we're all learning together.
We're gonna still learn together. Yeah.
But it's also interesting to see how you're bringing about community engagement. And also, we're talking about hydrological cycle. and understanding how it's changing with demand and climate change,
Mm-hmm.
but also bringing in the social aspect
Mm-hmm.
of it, which I find really interesting.
Yeah.
And by the time I'm coming to learn, that's IIASA is well known about systems analysis, and bringing all these aspects together is quite interesting, and seeing also within the model.
Yeah, I agree.
But so far, with as the science communicator, just interested with in terms of interaction with you talked about community engagements. Is there anything that you find is not within the model, or you usually add little within the model?
Something that we can better represent within the model, specific, we focus on, so a mix of engineering, like reservoir operations, is also related to how humans manage water. That's really important to properly simulate the water cycle. But irrigation practices, not just of big or large-scale farmers, but also of small-scale farmers, flooding paddies, how water is released, how water is brought onto fields. So irrigation practices, reservoir management, where and when groundwater is abstracted or pumped to be used for irrigation. We have domestic, industrial. Okay, perfect. It's at this place. Can we click initialize git LFS? This stands for large file storage. So we have some large files here. Okay, perfect. So we have downloaded the CWatM repository, CWatM Earth 30 minutes, the input, the virtual Earth repository. Let's, that's all we'll do for now. Let's continue the download of the climate data, and then we'll meet again next week.
Okay, thank you, Mikhail. Just a summary to know if I've gotten right the lessons of or today's lessons. So first of all is you get the climate data through the CWatM, if I'm not wrong, something of in that line, and then the GitHub Desktop, and then the inputs. But so far today, that's what we've done.
And the model, yes.
Okay, got it.
But before we forget, let's push play on the download of the climate data.
Climate data. Okay, yeah, that's true. Please don't be like me and forget.
We have each other.
Yeah. Resume. We have a problem. But we can figure it out, and also I can start again the download.
Okay, I think to start it again, do you know where to find it again? We can go through it. It's the second tab.
Between this, that.
Oh, you have the Google Drive link still open, the third one, or the fourth. The fourth one is the best, so download anyway. Okay.
Got it.
Now the connection's going to get slow, so, well, we say goodbye. It was a pleasure, Stephanie.
Thank you so much, Mikhail.
Likewise. Till next time. Cheers.